So in question 14, we've got a quadratic sequence and we're supposed to find the nth term. And the first thing we need to do is find the second common difference. Now, if this is a quadratic sequence, it must be in the form of an squared plus bn plus c. And what we've got to do is find out what all these coefficients are. And n, of course, is the column number of our quadratic sequence. Let's find that second common difference. The difference between 11 and 5 is 6. And I'm going to write it in between. This is 10, this is 14, and this is 18. And I think you can see fairly quickly we have a second common difference of 4, 4, 4. So by the rules of this technique, I can say, therefore, 2a is equal to 4 and a is equal to 2. So we have our first answer. Now, there are two ways to go on here. What you could do now is take away the effect of the 2n squared term here, take that away from the whole sequence and create a new sequence, which is just bn plus c, and work out what b and c are from that new sequence. The way I prefer is a slightly cleverer way, and it relies on the fact that we know what this number is. 5 is the result of substituting n equals 1 into this formula. So if n equals 1, 5 must equal a plus b plus c. And what about this number? Well, 6 is equal to the substitution of n equals 2 into this equation, which is 4a plus 2b plus c minus a minus b minus c. And I hope that makes that clearer. This is the substitution of n equals 2 into our quadratic sequence. This is the substitution of n equals 1. And taking them away, we got an answer of 6. So taking them away algebraically, the c's disappear. And I get 3a plus b. So we've got two simultaneous equations. We know a is equal to 2, and we can solve for b and c. Those are our two simultaneous equations. So it's fairly easy. Straight away, equation 2 is 6 is equal to 3a plus b. We know a is equal to 2, so therefore I can say b must be equal to 0. So if I now substitute a is equal to 2 and b is equal to 0 into the equation here, I get that c is equal to 3. And those are the three results I need, so all I need to do is now substitute them back into our main equation. I get the quadratic, effectively nth term, is equal to 2n squared plus 3. b, remember, is equal to 0, so this term disappears. And that's the answer to question 14.